Supplemental math videos from Circle Christian School.
Exponents are very powerful things. They describe a real number that has a base and a power to it. Scientific notation is one of those things that describe very large, very small numbers using the powers of 10. Anything that has repeated multiplication to it can be written in what we call exponential form. You'll find a set of the exponent rules in your book. Now, all exponents have to be simplified. I like to use a system of expanding them and then condensing them, making them, bringing them to my next license plate tag, where you put number to number and then letter to letter as you work through these. Now, as I look at the first example that we have, you'll notice that there are generally just things happening inside the parentheses. There aren't any powerful things on the outside of the parentheses. So these are just factors being multiplied together. And again, I'm going to use my number to number and letter to letter. I'll put my numbers first, any factors that are numbers. Then I will work my way down the alphabet. We have an x squared. Go from left to right. It helps to do that in such a way that if you're consistent going left to right, you'll cure a lot of those silly little mistakes. And then we have the y. So I have a number, I have a letter, and then a letter. And now we can use our power rule number 1, the 3, and then we have x squared times x to the first power, and it does have a little power of 1 there, even if it doesn't. Numbers too have a power there, even if it's not defined, it's at least a 1. And so we'll have x to the third power, adding the powers together, power rule number 1, and y to the fourth. Next example is a little bit more complex. You'll notice that on the outside of the parentheses is a power. And so I'm just going to expand the parentheses. That allows me to take a exponential expression here, and to simplify it, I just pretty much bring it back down to power rule number 1. And so it says power 2, so I'm just going to do it twice. And then I'll revert back to my number to number and letter to letter. And we have a -5 times a -5, which is going to give us a positive 25. And we have an x to the negative third power times x to the negative third power. Power rule number 1, add the powers. So we have a 25, x to the negative 6. And you'll remember that all negative powers are illegal. So we're going to have to slide it over the fraction bar. The 25 does not slide. It doesn't have a negative power. The power goes with, again, the symbol in front of it. The symbol here is an x. So the 25 is going to stay up in the numerator. And we're going to slide the x down over the fraction bar so that we can have a positive power. Now, another way to look at this is to use power rule number 5, which is the power of a power. And we can actually power to all the powers inside here. Remember that the 5 does have a little invisible power of 1. And so that is saying that I would have -5 to the power of 2, which would, and you have to kind of remember that what we're really saying here is -5 to the power of 2. So that's going to give you your 25. And then the 2 times the negative 3 is going to be x to the negative 6. And again, you'll just slide it down over the fraction bar to make it positive. Let's try a couple more that are a little bit more complex, but you just have to kind of revert back to your rules again. I'm still going to do my number to number and my letter to letter. I'm going to expand and I'm going to condense. So we have the 12 with the 6 are all factors here. I'm going to put my x's together. I have an x squared. Start at the bottom, then take a look. Start at the top and then take a look at the bottom. We have that negative power again, so we're going to slide him over the fraction bar. So he now has a positive power. It's okay to put the 1 with it. And we're going to take a look at the y's. The top one has that negative 4 to it, so he's going to have to slide over the fraction bar to become positive. So we have y to the 4th, and the y to the 2nd is going to stay right where it's at because he's already positive. And now we're just going to simplify things. The 6 is going to go into the 12 twice. And you'll notice the 2's up in the numerator up top. So he's going to go there. X squared times x to the 1st. Add the powers. X to the 3rd. And the y's are down below. Y4 times y2. Add the powers. So we get y to the 6th. Now the next one has a very special case where on the outside here we have a negative 1 for our power. Okay, I hope I didn't mess that up too much. Let me kind of white it out. There we go. And we'll start over. I'll put a negative 1 out there. There we go. Hi. Okay, so he's on the outside of the parentheses here. Anytime you have a negative power on the outside of the parentheses, what it is really, really telling you is you are going to have to flip everything on the inside. You can either do that at the first or do it at the end, because once we get to kind of having a little complex exponent here that generally you're going to follow your order of operations, do things inside the parentheses first. You can do some simplifying on the inside here. And then work your way toward the outside, or you can take a look at some of the outside things and work that way using your power rules. But again, I'm a fan of expanding and condensing. And I'm going to work inside, then work some outside magic. I'm going to go letter to letter, so I have x squared, and I know it's a capital X there. Microsoft does funny little things in a default mode. It's really a little x. So, and we have x to the 1st power here, and then we have a y to the 3rd and y to the 2nd. So I can simplify inside here. It's still all to the power of negative 1. And we have x2 times x1. Add the powers, x to the 3rd. There are 2 y's down below. I very rarely use power rule number 2. I'll just cancel from top to bottom. There are 2 down here, 3 up above. So we're going to take 2 out of the 3, and that's going to leave us with 1 y. So y to the 1st. And there's nobody down below here. And this right here, again, is going to tell me that I'm going to have to flip these. And here's the reason why. That if we use power rule number 5, the power of a power, and multiply it to all the powers inside, we would have x to the negative 3rd and y to the -1. And you'll notice that they've taken on a illegal look to themselves, and they're going to have to slide over the fraction bar. Thus just changing their place. So I'm going to show you another one that's going to use pretty much the same idea here. And I have really nothing to do inside here, so I'm just going to deal with my powers on the outside. Deal with exponents, you're dealing with powers, and anytime there's a -1 out here, we're just going to flip the insides. So my y to the second is going to come up above, and my x to the third is going to come down below, and now we've got a positive power. Everybody flipped. And to just see this in real time here, power rule number 5, distribute the power to all the powers, would leave us with x to the -6 and y to the -4 down below. And we would end up having to flip them anyway at this point. So I'm going to have y to the 4th and x to the 6th, slide them over the fraction bar, make them positive. If we were to expand and condense the top here, I'm just going to show you that basically you end up with the same thing. There's just kind of 3 different ways to get there. Just use a rule, you'll be okay. So this is actually y to the 2nd times y to the 2nd over x to the 3rd times x to the 3rd there. And we're still going to end up by using power rule number 1 with y to the 4th and x to the 6th. And you have become star powerful. Now go out and use some of that exponential power.